questions 1 through 4 on the 2008 grade 12 Euclid math contest. In the diagram, what is the perimeter of ABC? Obviously, we're going to use Pythagoras at least twice probably in this question. So the first one I will use on this triangle right here, ADC, and that will help me calculate the value of DC. So DC squared plus 12 squared is equal to 20 squared. So DC squared is 400 minus 144, and therefore that is 256. So DC is equal to 16. So let's put that there, 16. And then now I'm going to figure out the length of AB using this triangle, ABD. In that triangle, AB squared is equal to 12 squared plus 9 squared. And therefore that is 144 plus 81, and that is 225. So therefore AB, if you take the square root, will be 15. So label that 15. And therefore the perimeter will be, let's see here, 15 plus 9 plus 16 plus 20. And that is equal to 60. So the perimeter of triangle ABC is 60 units. In the diagram, the line segment with endpoints A0 and 8B has midpoint 54. What is the values of A and B? Well, the midpoint formula, you take these two and you add them and divide by 2. So 8 plus A divided by 2 and B plus 0 divided by 2. That is the midpoint of this and this. And they tell you that midpoint is 5, 4. So this guy corresponds to the 5, and this corresponds to the 4. So that means 8 plus A over 2 is equal to 5, and that means 8 plus A is equal to 10, and therefore A is equal to 2. And then we use this relationship, which is basically just B over 2 is equal to 4, and therefore B is equal to 8. So there we go. A is equal to 2 and B is equal to 8. The lines AX plus Y equals 30 and X plus AY equals K intersect at the point 612. Determine the values of K. AX plus Y is equal to 30 and X plus AY is equal to K. So those are our two equations. And how do we approach this? Several ways. Just isolate for Y, I guess, in one of these. That should be sufficient. But I think an easier way is just to use the fact that they've already given you the intersection point, 612. So when XY is equal to 612, that offers a solution to both of these equations, this one and this one. So I'll just substitute that in. Why make it more complicated? So when X is 6, this becomes 6A, Y is 12 is equal to 30. I substituted 612 into that equation. So solving, I get 6A is equal to 18, and therefore A is equal to 3. Okay? Then I'll do the same thing with that equation, substitute 612, and that gives me 6 plus AY. A is 3, Y is 12, is equal to K. So 6 plus 36 is equal to K, and therefore K is equal to 42. And that's it. Each part of this problem refers to the parabola y is equal to x minus 2 times x minus 8 plus 7. The points 2, 7, and C7, where C is not equal to 2, lie on the parabola. What is the value of C? Okay, if C7 is on this parabola, then it satisfies this equation. So that equation is y is equal to x minus 2 times x minus 8 plus 7. Substitute the point C7. So my y is going to be 7, and my x will be c. C minus 2, c minus 8 plus 7. Subtract 7 from both sides, and I get c minus 2 times c minus 8. And therefore c is equal to 2 or 8. But they're telling me that c is not equal to 2, therefore c can only be equal to 8. So that solves part A. Part B, what are the coordinates of the vertex of the parabola? Now, I have no idea what this parabola looks like, but let's just say it looks like this, right? I don't know, but if it does, then the vertex is that point right there. This point, which in this case is the lowest point. If it pointed downward, then it'd be the highest point. So how do we find that? The vertex of a parabola can be found very easily if the equation is in this form, ax minus h squared plus k. If the equation is in that form, the vertex is simply hk. So what I have to do is take this and convert it into that form. Okay, so that shouldn't be too much of a problem. All right, let's go with what we have. Y is equal to x minus 2 times x minus 8 plus 7. So let's expand that first. So we get x squared minus 10x plus 16 plus 7. Therefore, y is equal to x squared minus 10x plus 23. Okay. Now, how do we get it in that form? You have to do something called completing the square. And completing the square is pretty straightforward. I'll show you how to do that. What you do is you take this number, the coefficient in front of x, take half of it and then square it. So minus 10 is the coefficient. Take half of that, which would be negative 5, and then square negative 5. So if I do that, I get plus 25. And then immediately you have to subtract it. And then, of course, don't forget about that guy there. And what this does is allows you to factor that. And in our case, it becomes x minus 5 squared. And then these two combine in this question to give minus 2. And there you go. You got it in this form by completing the square. And now the vertex is very straightforward. If you look at that equation, the vertex will be equal to 5, negative 2. Now let's look at part C of this question. A line passes through the point A50, intersects the parabola at B4, negative 1. Determine the other point at which this line intersects the parabola. I'm going to draw just a really rough sketch just to illustrate this question. The sketch is just for aid purposes. So we have been told that this parabola, I don't know what it looks like, but let's just say it looks something like this, right? And there's a line that passes through 5, 0, and it intersects the parabola at 4, negative 1. Now this parabola we just figured out had a vertex of 5 and negative 2. So if this is 5, this is negative 2 approximately. Here's the vertex, right? So they're saying this line passes through 5, 0, so it passes through this point, and it intersects at 4, negative 1. So 4, negative 1 is, I know it's not drawn to scale, but that's okay. Approximately here. So we've got a line like this. And don't worry if it's not drawn to scale. I'm just illustrating this to help you. So they obviously want you to figure out this point right here, that point. They've told you this point is 5, 0. So I'll just put that in there, 5, 0. And they tell you that it intersects at 4, negative 1. Like that. Okay? All right, so how do you find that point? Well, you have to find the equation of this line. So, like all lines, it will have the form y is equal to mx plus b, and then we are given 2 points on that line, so we can use those 2 points to figure out what is y equals mx plus b. And those 2 points are 5, 0, and 4, negative 1. All right, let's start substituting. So substituting this guy gives me 0 is equal to 5m plus b. Okay. And then substituting the other point, this one right here, gives me negative 1 is equal to 4m plus b. All right, subtracting these two equations will give me m is equal to 1. Yeah. All right, straightforward. Substitute that back into here. That means that y is equal to x plus b. And then finally, any of these points will give me the value for b. If I substitute 5, 0, I'll get 0 is equal to 5 plus b. And therefore, b is equal to negative 5. So my equation is y is equal to 1x minus 5. 1 was the value for m. So it's just x minus 5. Okay. So I've got my equation for this line, y is equal to x minus 5. And then this parabola, that's the parabola from the previous question, right? Yeah. Yeah, exactly. I was getting worried. What's the parabola? And that parabola is x minus 2 times x minus 8 plus 7. Right here, they give you that equation right there. So how do we find the intersection point? Well, that's easy. You just set this equal to that. So here we go. So we've got x minus 2, x minus 8 plus 7 is equal to x minus 5. And this will give us the solution. So expanding, we get x squared minus 10x plus 16 plus 7 is x minus 5. Put everything on one side. So let's see here. X squared minus 11x, 23 plus 5, so 28 is equal to 0. And I think this factors. So I've got x, 7, and 4, negative, negative. Yeah. So that means x is equal to 4 or 7. Well, the 4 is this guy right here. So this point obviously is going to be the 7. So x is equal to 7. When that happens, we have to figure out the y coordinate because they want the actual point, right? Yeah, so they want the both x and the y coordinates. Y we can get just by substituting into either of these equations, either this one or this one. I'll just use this one since it's easier. Y is x minus 5, so it'll be 7 minus 5, which is 2. So therefore, this point right here is 7 and 2. A 3 by 3 square frame is placed on a grid of numbers as shown. In the example, the sum of the numbers inside the square frame is 108, and the middle number is 12. When the square frame is moved to a new position, the sum of its numbers becomes 279. In the frame's new position, what is the middle number? What is the approach to this question? Do we just start picking frames and adding numbers? Well, no, that's going to be crazy, right? So what I'm going to do is just draw what they chose initially and show you the relationship between these numbers, and that will make perfect sense, I hope. So I'm going to let the very first number be x. The next number after it, obviously, is x plus 1. The next number after that is x plus 2. So that part is pretty straightforward. But what about these guys? Well, if you look at it carefully, especially if you look at the entire table, you'll notice pretty quickly that is x plus 7. Okay? No matter where you chose the original number, the one below it will be always x plus 7. And therefore, this one is x plus 8, and this one is x plus 9. And in a very similar way, the row below it will be x plus 14. and therefore this one is x plus 15, and this one is x plus 16. So no matter what you choose, here, 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 wherever, all the numbers will be of this form. So we have to add them up and ensure that the total is 279. Okay, so let's do that. Let's add up all these guys. If you do, I get 9x plus, let's see here, 3 plus 24 plus 45, and that must equal 279 according to my question. So this is 9x plus 72 is equal to 279, and therefore 9x is equal to 207, dividing through x is equal to 23. So 23 is the first of this 3 by 3 grid. So go to our master grid, find 23, and then draw a little 3 by 3 grid with 23 as my first number. And they want to know what is the middle number. Well, the middle number is 31. So middle number is 31. And you can verify the sum by adding these guys if you want to, but I assure you it'll equal 279. Of the 3 figures shown, which has the smallest area and which has the largest area? Explain how you determined your answer. In figure A, the circle has a diameter of length 2. Okay, so area of the first guy is pi r squared since it's a circle. Now the diameter is 2, so therefore the radius is 1. So this is just pi. And that is approximately, as you know, 3.14. All right, let's turn our attention to B. B is not as quick in terms of its answer. First thing, of course, is we're going to need a height like that. And then this is equilateral, right? My line kind of hid that right there, but it's equilateral. And if it's equilateral, then that means that if you were to look at the angles, they're all 60 degrees. So that means this is 60 degrees right here, and then this is a perpendicular, so that's 90, and therefore this guy is going to be 30. So that's a 30, 60, 90 triangle. So from here to here is 2, so from there to there is going to be just 1. And then I can therefore find h using the 30, 60, 90 triangle ratios. Any 30, 60, 90 triangle, the ratio of the sides are 1, 2, and root 3 for this guy right here. So using those ratios, h over 1 is equal to root 3 over 1. So therefore h is equal to root 3. So the area of that shape is 2 times the area of each of the triangles, and those two triangles are the same. So 1/2 base times height, the base is 2, and the height we just calculated is root 3. So this becomes 2 root 3. And in decimals, 2 root 3 is equal to approximately 3.46. Okay, moving along to this figure C, this one, let's see here, we'll just call this side x and this side x, and they're equal. That's what those symbols mean. So using Pythagoras, x squared plus x squared is equal to 2 squared. So therefore 2x squared is equal to 4, and therefore x squared is equal to 2. Now the area is again 2 times 1/2 base times height, because there are two triangles that are identical. Or another way is to understand that this is a square, and the area of a square is just x squared. So that's 2. So there you go. So now we have to figure out which is the largest, which is the smallest. The largest is this guy right here. It's 3.46. So the largest is B. So I'll put the largest is B. And the smallest is right here. The smallest in terms of area is C. A flagpole FP is 20 meters tall. From point A on the flat ground, the angle of elevation to the top of the flagpole is 40 degrees. If B is halfway from A to F, what is the measure of angle FBP to the nearest degree? All right, FBP, this angle right here, so I'll just call that theta. And off we go. And this AB I'll call X, and then B to F I'll call X also, because those two are the same. So we're going to use trigonometry. And in trigonometry, we have tangent. And in the big triangle, that one right there, I'm going to use tangent of 40 degrees. And it is opposite over adjacent. Opposite is from P to F, which they tell me is 20. So that equals 20. And adjacent is 2x, according to the way I labeled it. So 2x, therefore, is 20 over tan 40. And using your calculator, you'll get 23.835, and therefore x is equal to 11.917 approximately. Okay, but that's not what they want. They want the angle theta. Okay, no problem. I can use this triangle and again use tangent. So this time it's tan of theta is opposite, which is 20, over adjacent, which is x. And I just figured out x, so it's 20 over 11.917. All right. So if you do the math, you get tan theta is equal to 1.678. And then if you do the inverse tan, you get the angle. And the angle is approximately 59.2. And they want it to the nearest degree. So to the nearest degree is just 59 degrees. In the diagram, AB is 21, BC is 16, and angle ABC is 60, CAD is 30 degrees, and ACD is 45. Determine the length of CD to the nearest tenth. All right, very quickly we can figure out that that's 105, right, because the sum of the angles of a triangle are 180. And let's see, where do we go from here? I guess the law of cosines, this question sort of screams law of cosines. They've set it up in the perfect way. So the first thing I want to calculate is CA. So using the law of cosines, CA squared is equal to 16 squared plus 21 squared minus 2 times 16 times 21, the cos of 60. Right? If you're in grade 12, you're writing the Euclid, I'm sure you know the law of cosines. Doing the math here, you get 256 plus 441 minus 672. Cos of 60 is a half. And then this is going to be 697 minus 336, and that is 361. So take the square root, and you get CA is equal to 19. So there you go. Got 19 for CA. Now, what do they want CD? They want this length right there. Okay. Well, to get that, I'm going to use the law of sines. Law of cosines, and now the law of sines. So CD over that angle opposite it, which is 30, is equal to CA over the sine of the angle opposite that, which is 105. And there you go. This will allow me to solve for CD. CD sine of 30 is 0.5. CA I just figured out was 19, and the sine of 105 is 0.9659. Solving for CD, you will get approximately 9.8.